Okay, so we have this theorem. A covering projection is a vibration, right? That is for so what we'll do. So we have assumed that P from x tilde to x is a covering projection, and f prime from y to x tilde and capital F from here to here we map such that this holds. We want to prove that there is f prime from here to here such that this holds. Now, to prove this, we shall prove that for each y in capital Y, there exists an open neighborhood y of y in capital Y and map and a map fy prime from here to here such that fy prime composed P equal to uh, your this is equal to f restricted over ny cross I. Restricted over ny cross I. And this and f prime y come applied over y prime comma 0 equal to f prime y prime for all y prime belong to ny. Right, so we'll do this. Now, if we have such a thing, right, for each y in y, we have such a map, right, which with this property, then let us see what happens, right? Assume that we have such neighborhoods ny and maps f prime y right. Now, if y double prime belongs to ny intersection ny prime, then what we have is following. Then this f y prime restricted over y double prime, this singleton, right? I am just writing like this. Then this restricted over this and capital F prime y prime restricted over y double prime cross I. So it means when I write like this, it means y double prime cross this, right? Then these maps over this then these maps, right, are maps on a connected of the connected connected space y double prime cross I. You just see here that this is singleton. This is a homeomorphic to I itself, and I is connected. So this is connected. Then it is there are maps of the connected space uh, this into x tilde such that for P belonging to I, P composed F y prime intersect restricted over yes y double prime cross I applied over double prime comma T, right? This is basically by construction. You just see here this one. So this is basically F applied over y double prime comma T. And it is actually equal to P composed F prime y prime restricted over y double prime I y prime T, right? So basically these two maps are lifts of same map this. So this map is defined, just see this map is defined, so here, yeah. So this basically, when this one, we can just write this restricted over y prime cross I, right? From here to x, right? Basically here we can write this. So this map is a map from a connected space this to x, and these two maps are lifts of this one, right? And they agree actually at following like this. Also, f prime y restricted over y double prime cross I applied over y double prime comma 0 equal to f so this is basically f prime y double prime equal to f prime y prime restricted over y double prime cross I y prime y double prime comma 0, right? So basically they agree at this point. So these two maps, they agree at this point. So in the previous result, we have seen that if you have a two lifts, right, of a same map defined on a connected space, then and if they agree at one point, then they will be actually identical. So they should be equal, right? Hence, by using previous theorem, uh, by previous theorem, f prime y restricted over y double prime cross I equal to f prime y prime restricted over y double prime cross I, right? This. So what we have actually, for every y belonging to capital Y, we have got an open neighborhood ny. For every y belonging to capital Y, we have got an open neighborhood ny of y such and a map f from f prime y from ny cross I to x tilde such that uh, it is a lift of this f restricted over capital F restricted over ny cross I, and it agrees with f prime on small f and we have f prime y y prime comma 0 equal to f prime y prime. Okay. So since this is true, this is true for all y double prime belonging to ny intersection ny prime. We have uh, fy prime restricted over ny intersection ny prime cross I equal to f prime y prime restricted over ny intersection ny prime cross I. We have this. So what actually we have, we just see here that this y cross I, right? This in this y cross I, this your ny cross I, this is an open set, right? In y cross I, this is open. So on these open sets, we have defined fy, right? So we can glue this because this fy, if we have fy and fy prime, then if they agree on this ny intersection ny prime cross I, intersection of this is what? This is ny cross I intersection ny prime cross cross I. Intersection of these two is this. So fy, these and this, they agree over this, right? So it means that we can glue, right? So we can use gluing lemma, right? So we can glue these maps to get a single map, right? So hence there exists a continuous map f prime from y cross I to x tilde such that f restricted on ny cross I equal to fy prime. and f prime is a lifting, right? Lifting of f such that f y comma 0 equal to uh, f prime y comma 0 for all y belonging to R. So this we have, this is there because of this and this, because f y prime is actually lifting of f restricted over ny cross I, right? Such that corresponding property to this holds. So we have this. This you can verify. Now, now let us see how we are going to get these fy primes, right, over ny cross I. So let us see how we are going to get it. So since P from x tilde to x is a covering projection, since this is a covering projection, what we have is there exists a covering u alpha of x by open subsets, right, of x evenly covered by P, right? So because this is a covering projection, we have a open covering of x, right? Each member of it is evenly covered by P, right? Now, this uh, uh, capital F inverse u alpha, right, is an open covering of y cross I. Okay, because your map f is from y cross I to x. So if u alphas cover x, then f inverse u alphas are going to cover y cross I. Okay. Now, for each uh, y belonging to capital Y, this for each y belonging to capital Y, this y before that we'll just do this. Since this F inverse U alphas are open sets in they are open sets in Y cross I, and uh, we have F inverse U alpha equal to union of some V alpha, let us write V beta cross uh, open intervals. We can take A beta, B beta, such that right, because of course these are basic open where V beta is where V beta is open in Y, right? So of course, because these are basic open sets in Y cross I, so we can have something like this. Uh, Basically, we can this, right? So such that uh, F applied over V beta cross A beta comma V beta, this closed interval. This is completely contained in U alpha, right? So we can get it uh, uh, yeah, in some U alpha prime, right? So it may they most of them will be in a U alpha itself, but when you put closed interval here, so some of them may be inside some other U alphas, right? Uh, so we can have something like this. Okay. Uh, so clearly, clearly this y cross I can be covered by uh, uh, subsets v beta cross a beta comma b beta such that uh, f of v beta cross a beta b beta closed interval is contained in this is contained in an evenly covered open subset u alpha prime of because of this, and f inverse u alphas they cover y cross I. Y belonging to I y belonging to capital Y cross I. Y cross I means singleton Y cross I is a compact set and is covered by open sets b beta cross a beta b beta such that the f applied over v beta cross a beta b beta is completely is contained in a single evenly covered open set u alpha prime of x. Now so because y cross I is compact and it is covered by some open set, so we are going to have a finite subcover. Hence there exists is a finite subcover there exists a finite subcover p beta 1 cos beta 1 comma b beta 1 v beta k cross a beta k comma b beta, right? So what we can do is that we can refine these sets. We can refine these a beta I comma b beta is, right? So of course they will cover this. So take take right ny equal to intersection of b beta I equal to 1 to 3. Okay. So of course this because y cross I they cover y cross I, right? So y belongs to this each of these, right? If it doesn't happen, then you can just throw that. That is not of any use. So y belongs to each v beta I, right? So their intersection also will contain y. So and each v beta I is an open subset of capital Y. So this ny is open subset of capital Y containing y. Uh, so what you have is, so this is your closed interval 0 1, right? So this uh, we can have this a beta 1 b beta 1, right? Something like, so we can have intervals like this, these intervals, something like this, right? So of course they will cover this I, right? So we can define them, right, in such a way that we can choose these intervals just like this. So like this. So we can just choose a middle point here, then we can choose another point, something like this, right? Right. So we can refine the intervals was a beta I, b beta I, such that to get to get to get a sequence t naught t1 tn m equal to 1, such that uh, uh, such that for I equal to 1, 2, and so on m, this capital F applied over ny cross this ti minus 1 ti, it is contained in some open subset of X evenly covered by P. So we can do this, right? So because our intervals, as I told you, this a beta I, b beta I may be entangled, something like this, but we can refine, right? We can resize these intervals in such a way that this be such that we get these finite sequence such that this is contained in some open subset of X. Now, Now we show that we so that we shall prove that we shall prove that uh, there is a map. There is a map f prime y uh, from ny cross I to x tilde uh, such that uh, P composed Fy prime equal to F restricted over Ny cross I. How we are going to do? Uh, so there is a F prime Y from Ny cross I to uh, X tilde with the desired properties that we have discussed. That is, it is a lift off. That is your P compose F prime Y equal to F restricted over uh, Ny cross I and Fy x comma 0 y prime comma 0 equal to f prime y prime for every y prime belonging to ny. So to uh, to get this, it is enough to define such a uh, such maps uh, uh, or to get such maps maps f prime y from ny cross I to x tilde. It is sufficient to define maps GI from NY cross NY cross TI minus 1 TI to X tilde I equal to 1, 2 and so on M, such that GI composed P equal to F restricted over NY cross TI minus 1 TI and this G1 Y prime cross comma 0 equal to F prime Y prime for every Y prime belonging to NY, and GI minus 1 Y prime comma TI minus 1 equal to GI Y TI minus 1 for every Y prime belonging to NY and I equal to 2, 3 and so on. So to get such maps Fy prime from here to here, it is sufficient to define maps GI with this property because given such maps GI, GI there is a map. We can glue these maps GIs because you just see that because given such maps GI by gluing them using gluing lemma or twisting lemma, there is a map. We get a map F prime Y from NY cross I to X tilde such that Fy prime restricted over NY cross TI minus 1 comma TI equal to actually GI for every I equal to 1, 2 and so on. And also in this case Fy prime will have the desired properties. Fy prime, Fy prime uh, will have the desired properties, right? So you one property was that because if this f y prime restricted over this is this, and gi is lift up this, right? Uh, so it means that this fy prime also will be a lift of this f restricted over ny cross I, and this similar property for fy prime will hold, uh, right? Uh, so thing is that how we have done it. So what we are having actually ny cross ti minus 1 comma ti. So I equal to uh, 1 to m, right? So these are what? These are actually closed subsets of, these are closed subsets of ny cross I. Okay. Now, this can be written as these union of these. So these are finitely many. So if you can write a space as finite union of its closed subsets, right? Uh, and if you can define a continuous map at each of these finite, uh, at each of these finitely many closed subsets, so that on the intersection they agree, that is something like this. For example, if you take something like this, and if you take any other uh, ny cross ti plus 1, other closed subsets for I equal to for other values of I, they will not intersect with this. So this will intersect only with this, and what will be the intersection point? Ny cross uh, cross ti, right? This will be the, and at this point the two maps will agree, right? Hence by gluing lemma there exists a continuous map ny cross I defined on ny cross I to x tilde with the desired properties, so that you can verify. Now, so let us see how we are going to define the maps GIs. So we define the maps GI using induction, right? So we'll start with G1, then we'll define G2, then and so on, induction on I. Okay. Uh, First we will define G1. So let U be an open subset of X evenly covered by P, evenly covered by P, such that F applied over Ny cross T naught comma T1, right? T naught comma T1 is contained in U, right? Completely contained in this evenly covered open set. Let Uj tilde be a collection of disjoint open subsets of x tilde such that P inverse U equal to union of these J tilde uh, right. So P inverse U is union of these Uj tildes, and P maps each Uj tilde homeomorphically onto U. Okay. Uh, just a minute. Now, next, let Vj equal to F prime inverse Uj tilde. Then, then uh, Vj tilde, sorry, then Vj is a collection of disjoint open subsets of Y covering Ny. Now, how it is? You just see that uh, this F P composed F prime equal to actually F applied over Y prime comma 0. Now Y prime comma 0 for every Y prime belonging to Ny. Now Y prime comma 0 is a point in Ny cross uh, T naught T1. Okay. So if we restrict restrict this coordinate and we vary Y prime in Ny, then means uh, uh, this f y prime comma 0, it belongs to f y prime comma 0, it belongs to U, right? So basically what we have is uh, this P inverse U, right? uh, so P inverse U, it will contain actually uh, this image of this. So P inverse U is going to contain this F prime Ny. This is going to be contained in this. Okay. Hence, this uh, if you just consider Ny is going to be contained in F prime. So you can just apply, yeah. So F prime inverse. What is this? These are these uj tildes. So this uj tilde union of over this, right? So this is basically your union j vj, right? So these vj's, they are open sets, of course, because these uj tildes are open. F prime is continuous. So this, and they cover this ny. Now define G1 as the unique map such that for each, and because these uses are disjoint, of course these uses will be disjoint. Uh, so we define G1 as the unique map such that for each j uh, G1 maps Vj T naught comma T1 into uj tilde to uj tilde to be a lifting of f restricted over bj t naught t1. Yeah, so this of course we can do because you just see here that uh, so we can define basically uh, so basically what we can do is we can define this uh, gi gi g1, here we define g1 first, g1 to be f restricted this is f restricted over bj cross t naught t1 composed with p restricted over uj tilde, right, and its inverse, right? So p over uj tilde is a homeomorphism from uj tilde to u, right? So here you have this. So here you have Vj across T naught, T1, right? Here you have uj tilde, and here you have f applied over this. Uh, it is inside u, right? And p applied over this is a homeomorphism from here to here, right? So you want to define this G1, right? So you want to define G1. So you can define it to be from here to here. How? You just consider this composed with this, right? If you do that, then it will satisfy that thing P. If you compose this, so this will be G1, right? So G1 composed P will be this. If you define like this, okay. So clearly, this G1 composed P equal to F restricted over Vj plus T naught. Next, we define G2 and then G3 and so on. Suppose that we have defined Gi minus 1. Assume that Gi minus 1 is defined for I equal to 1, right? So, what's this? I equal I greater than 1 and less than equal to, yeah. Suppose for I equal to 1 already we have defined. So assume that it is defined Gi minus 1 is defined for I greater than 1 less than equal to m. Now we will define Gi. So so here we cannot take I equal to 1 because I minus 1 is then it will G naught. So we are not talking about G naught, right? So we are starting with G1, right? So suppose we have this. Now let U prime be an open subset of X evenly covered by P such that F applied over Ny cross uh, Ti plus 1 we are going to define Gi. So here we should have I minus 1 Ti. It is contained in U prime. Let UK tilde be a disjoint collection of open subsets of X tilde such that your P inverse U prime equal to we are taking UK tilde prime. Okay? It is union of k over this uk tilde prime and p maps uh, uk tilde prime homeomorphically onto u prime. Okay, for each k, for each k. Now let vk prime equal to, let vk prime be so already we have defined gi minus 1. Okay, uh, so this is y prime in ny such that gi minus 1 uh, gi minus 1 y prime comma t I minus 1 is contained in uk tilde prime. Right. So basically, if you consider g means you are restricting the second coordinate. So if you consider gi minus 1 to be a function of uh, just first variable, because you are restricting, you are keeping this fixed, right? The second coordinate. So basically, if you just write like this, t I minus 1 inverse over uk tilde prime, something like this. Right? So it is this, and it is going to be open, of course, in y. Then vk prime is a disjoint collection of open subsets of y uh, covering ny, covering ny. We define gi to be the unique map to be the unique map for such that unique map such that for each k gi maps vk prime cross ti minus 1 comma ti into uk tilde prime to be a lift of this f restricted over vk prime ti minus 1 comma ti, right? So again, we will do same thing. This we will consider uh, this GI to be uh, P restricted over U K tilde prime inverse composed F restricted over V K prime plus Ti minus 1 Ti. So you can see that the GIs, they will agree at the specified set that we have discussed before. Uh, so we are defining these GIs in such a way that they agree with uh, GI minus 1 and GI plus 1, right? So they will, GI will agree, so GI will agree with GI minus 1 at NY cross Ti minus 1, and it will agree with Gi plus 1 with X on the set this, right? So because here you can see that similarly for G1 also, because P is a continuous map, P restricted over this is a homeomorphism, so its inverse is continuous, so this is continuous, this restriction is continuous, so composition of two continuous maps is continuous, right? And uh, yeah. Yeah, so this completes the construction of these GIs. This completes the construction of GIs, and hence the proof of the theorem. So we stop here.